discussion on material balances involving single unit non-reactive processes. And today, ang pag-uusapan natin is evaporation. Okay, so this is our second example. So ano ba yung evaporation? So evaporation is a unit operation. Importante siya sa mga chemical industries, maybe even in bioprocessing. Okay, so it's the separation of a volatile solvent from a non-volatile solute by vaporizing the solvent. Okay, and normally we deal with aqueous solution. So the solvent that we're talking about is water. Okay, now ano yung purpose ng evaporation? So evaporation, it's normally used to concentrate a dilute solution. So let's say, for example, you have a dilute solution of some kind of juice, let's say an orange juice. So you want to concentrate it to give more flavor, no? So you use evaporation. Okay, so the same with drying, it's some sort of removal of moisture or removal of water. Tama ba? So para silang removal of moisture. Ano nga lang ang pinagkaiba nila? So in drying kasi, you are removing less amount of moisture, while for evaporation, you are removing a large amount of liquid. Okay? So sa drying, konting amount lang ng moisture ang nare-remove, but for evaporation, large amount of liquid. Okay? Also, for drying kasi, it occurs below boiling point. Kasi di ba in drying, you normally use a air, right? And this air will remove the moisture content of your material. But for evaporation kasi, it occurs kasi nga you are vaporizing the solvent or your water. So therefore, it must occur at the boiling point. In drying, it's done. Okay, the purpose is to get a stable dry product, right? And you know the benefits of doing that, right? But for evaporation, talagang ang kanyang purpose talaga is to concentrate yung ating aqueous solution. And the emphasis for drying is on the solid product, while for evaporation, the emphasis is basically reducing the volume. Okay, so typical examples of evaporation are concentrating, aqueous solutions like sodium chloride, sodium hydroxide, and juices nga, like orange juice. Sometimes also milk, glue, glycerol. Okay, now in that case kasi, yung concentrated solution na product natin after evaporation, siya yung ating desired product. Okay? But in other cases, okay, in some cases, yung water, okay, na natitira or na-discard rather, siya yung ating desired product. These are, for example, you have water na nagko-contain ng very small amounts of minerals. So you want to remove the minerals or separate rather the minerals from the solvent water. Okay. So what we do is we can do evaporation so that the desired product is a solids-free na water, and use that as a boiler feed and some other special applications, okay, in chemical processes. Evaporation is also used, to evaporate seawater, okay, and that has a goal to provide drinking water. Now, in some cases also, the primary purpose of evaporation is to the same, concentrate a solution so that upon cooling, salt crystals will form and be separated. Okay, and that special evaporative process, we call it crystallization, and we'll talk about crystallization more in some other lectures. Okay, but for now, our goal or our discussion will focus on evaporation as a way to concentrate your dilute solutions. Okay, so here is a diagram of your evaporator. So I still use a block, okay, to show you the evaporator. So you have here a feed solution. Okay, that feed solution is of course normally dilute. So you want to concentrate it. So the product, we can call it concentrate. And of course, the solvent that you remove by vaporizing the solvent, okay, again, normally water siya, so we call it evaporate. Okay, so yan ang basic, diagram for an evaporation unit operation. Okay, so let's solve a sample problem for this. So you have here a sodium hydroxide solution being evaporated from 35.7% by weight of sodium hydroxide to 52.6% by weight. So mas concentrated yung ating desired product. Now, let's calculate the weights of evaporate and concentrate produced when 100-pound solution is fed to the evaporator, assuming the machine is 100% efficient. So let's solve this one. It's actually a very simple problem. Okay, you won't need some kind of, you will need simple equations for this. But first step again is to what? To draw the flow sheet, right? So I will use a block or a rectangle to do that. So let's show it here. Okay. Sorry for the extra markings. So say this is your evaporator. Okay, and of course you will have a feed, okay, which is a dilute solution. Now, yung feed natin, sabi sa problem, 35.7% solute daw. In that case, our solute is NaOH. So, aqueous solution lang naman to, right? So, in other words, you can compute right away kung ilan yung percent water doon sa feed natin. So, if you do your calculation, if you can use your calculator, lumalabas ng balance is 64.3, tama ba? Percent of water. So, yan yung composition po ni feed natin. Okay? So, how about the concentrate? Okay, so what is the composition of the concentrate? So, same, no, water and sodium hydroxide, but in what percentages? So, sabi sa problem, gusto natin, we desire to have a concentrate. So, let's use the symbol C for the concentrate. So, we desire that we obtain a 52.6% sodium hydroxide solution. So, given yan yung gusto natin. So, let's also compute for the balance. So, for water, therefore, we will have what? 47.4% of water. Okay? And ano pa yung missing stream natin dito? So, huwag kakalimutan na meron kang evaporate, okay? Or the moisture being removed by vaporization. And here, ang ating required, okay? What we're trying to calculate according to the problem, okay? So, required is yung ating evaporate and yung ating concentrate in terms of the amounts, okay? So, weights. Okay? And by the way, nakalimutan ko isulat, yung feed natin, 100 pounds daw siya. 100 pounds. Okay, so what will be our basis? Since given naman na 100 pounds, okay, it's a fact already na 100 pounds yung pinapasok nating feed. So that will be our basis. So you'll have a 100 pound feed. Okay? So ano yung susunod, 'di ba? We need to perform or write the overall material balance. So if you take a look at the flow sheet, paano yung overall material balance? Whatever is entering the system equals whatever streams are found in the outlet. So that's basically F equals what? E plus C, tama ba? E plus C. Now, we have already an amount for F, so we can go ahead and substitute. So 100 equals E plus C. Okay? So you have one equation, but you have two unknowns. So you need to find another equation. All right? And anong gagawin dyan? So after the overall balance, syempre, punta ka na sa component balance. Now, you can choose among two components. Okay? We have two components, which is sodium hydroxide and water. So you can use either. Okay? So let's go ahead and use NaOH. Okay, so for NaOH balance, di ba, basically NaOH in F equals NaOH in E plus NaOH in C. Tama ba? But then again, wala namang NaOH dun sa E because it's a pure component. It's just water, right? So ang matitira is NaOH in F equals NaOH in C. So let's go ahead and substitute whatever values that we have. So NaOH in F, di ba, meron tayo yan. That's 35.7. So 35.7 of F, okay, which is 100 pounds, equals NaOH in C. So do we have that? Yes, we have that. That's 52.6 okay, of C. But C is still unknown. So lagyan natin C. So in this case, we have produced an equation na isa lang ang unknown, right? So we can right away solve for C. So C is, therefore, if you use your calculators now, you'll get 67.87 pounds. Okay? So that is the amount of the concentrate. Okay? Now, ano pa ang ating hinahanap? So after looking for the amount of concentrate, yung ano naman, evaporate naman tayo. Okay? So for the evaporate, okay, what can we do? Well, all you have to do is to substitute this value of C. Okay? So let's say this is your equation 1, yung ating overall material balance. Okay? So what we can do is substitute C to equation 1. So substitute in equation 1. So that will be 100 equals E, okay, plus C. So what is C? That's 67.87. So therefore, you will get E equal to 32.13 pounds. Okay? So yan na yung mga hinahanap natin sa problem. Okay? E for the evaporate amount and C the amount of concentrate.